Okay, this is the page 6 and 7 running test review. I've already drawn the scatter plot for your graph that you have to do. I'm assuming that you guys are going to be able to do that. So now my next step is probably going to be to draw in the best fit line. This will be part B. Drawing the best fit line, what you're really trying to do is put a line in here that represents the trend of the data. As you can see here, it's kind of got a downward slope like this. I think I'm going to try to get it so that the points that I'm dealing with here, I have sort of an equal number on the top and the bottom. You have to be careful of this because sometimes it takes a couple of tries to get it right. You see, like that isn't bad, but it's not really right in the middle of the data either. I'm actually going to undo that and try it again. I'm going to angle it a little bit more. I like how this is going right here. So I'm going to go more like this. You see how I'm touching a few more of the points? And I do have some that are off, but this isn't too bad. Notice I'm bringing it all the way back to the y-axis. That's important. Actually, I'm still not totally happy with that. So I'm going to take it and I'm going to angle it a little bit more. Because I'm not too upset with the way it's drawn in, but I want to angle it a little bit more like that, I think. We might end up with an outlier there on the end, but I think that's a pretty good data set right there. Again, I want to make sure that this touches the y-axis. If it doesn't do us any good. So, there we go. Okay, that's your best fit line drawn in. Some key points to understand when you're doing this. If you notice, the distance between this point right here and these two from the line are basically about the same. And we got a little bit off there, but basically they're pretty much the same distance on either side. And then this one over here, it's not too far away, but I'm going to consider that kind of an outlier point, different from the rest. Okay, part C says to locate the y-intercept and to find the slope. You're going to need to do that because you're going to have to write an equation from this. So locating the y-intercept is as easy as saying that it's right here where it touches the y-axis. So the y-intercept is right there. So we need to give a value for it. So it looks like it's about 50. I did my y-axis every 3 blocks is 10, so it's kind of a pain, but I'm going to say about 52. My y-intercept equal to about 52. A little bit of estimating, but no big deal. I'm actually going to fix this real quick. Sorry about that. Okay, this should work a little bit better now. Alright, so that's the y-intercept, the slope. Alright, the slope, I need a point that crosses at a really easy point to tell what it is on my green line. Basically now I don't need the dots anymore for the most part. But I'm looking through this and I'm looking through here and I'm trying to find a point that crosses pretty easily. Actually, I like that point right there. So I would say not too bad. What does it take to get from where I'm at to that point? So I have to go from here. I'm going to go down. Let's see, I'm saying that this is about 5 places down. And then to the right, each one of these axes on the x-axis is by 10. So I've gone down 5 and right 30. Down 5, right 30. Which means I have a slope that's a -5 for the rise, and 30 to the right. And I should reduce that. Actually, 5 goes into both. On the top, -1, and on the bottom, 6. So my slope is -1/6. So for part D, when it says write an equation for the line, part D is really kind of simple. It's part D. Your equation is really easy, right? Because you're going to put the slope that you got in where the m would be, -1/6, x, And then the intercept you have, positive 52, over here. That's my intercept. So here you have your equation written. It says in part E, predict, using your equation, the mileage of a 290 horsepower car. If you look down here, we plotted all the horsepower on the x-axis. That means the horsepower goes in for x, and we'll get an answer for y, for mileage. So the 290 goes here. So I'm doing part E right now. That's going to take a little bit of calculator work, I guess. I don't know what 290 times 1 over 6 is, so I guess we can figure it out. Well, it turns out that that's equal to negative 48.3. Then I have to add 52. So I end up with a final answer of y equals 3.66 miles per gallon. So it tells you that our equation isn't totally great, because hopefully a car with 290 horsepower gets a little more than 3.66 miles per gallon. But that's what we got according to our equation, so we're going to run with that. F says, tell whether the correlation is strong or weak and positive or negative. I think because it's downhill, it's pretty clear to see that it's negative. And because the dots are relatively close to the line, they're not really spread out, I would call this a pretty strong correlation. So this to me is a strong negative. And finally, for part G, it says, describe what your graph indicates. I would say that in this case, the graph simply indicates that as the gas mileage, or excuse me, as the horsepower increases, the gas mileage decreases. Like I said, on your test tomorrow, or excuse me, on Thursday when your test is, your graph is going to be made for you. You'll have to draw in your best fit line, develop your equation, come up with a solution like in part E, and state the correlation in part F, and finally describe the graph in part G. All right, our next part of this is graphing systems of equations. These tend to be pretty easy compared to some of the stuff we've done afterwards. So let's take a look at these, and I think what you'll notice is that there's basically two types that you'll have to graph. The first kind is when you have an x and a y together like this. We call this the intercept method. It's where you set the x term equal to a number and then the y term equal to a number. So for the first equation, I'm going to just say x equals 4, and I don't have to solve anything because I've set the x term equal to a number. And actually the same thing for the y. So the y equals 4 also. This is an x-intercept and this is a y-intercept. So plot them on the x-axis here, and then this one on the y-axis here. And you can draw a line connecting the two. I might have to fix that one a little bit to angle it a little bit better. That's pretty good. And then the other equation is one where we actually have x and y on opposite sides. So I'm going to take that one and rearrange it a little. I'll subtract the 4. So I got 2y equals x minus 4. And then I'm going to divide by 2. When I divide by 2, this is x. Now it needs to be, or it's 1x. It needs to now be 1/2 x. And negative 4 divided by 2 is negative 2. So this is like a slope, negative 2, down here. Excuse me. Like that. In trouble. That's a y-intercept, negative 2. And then the slope is 1 over 2. So up 1 and right 2. It goes right here. And we can draw a line in from there. And this time, we can see that our line intersects at that point right there, which is what we're looking for. you can see the intersection of the 2 points. That's what you want to highlight and mark as your solution. That one right there, and it is over 4 up 0, which is our final answer. Just like that. The graphing equation doesn't involve shading or anything like that. It's strictly just, can you plot a couple of points, make a line, and find where the other line intersects it. All right, for number 43, we basically have the same kind of scenario, another one of these problems where we're trying to graph 2 equations. And this time we have sort of a mess. The bottom one isn't too bad, but the top one's a little ugly, I guess. I would say that, in my opinion, the best way to do that would be to subtract the 3x off. So I'm going to rewrite this one real quick right here so I can show you what I'm doing. I like to rearrange this one to make it broken into form. I would subtract 3x, which leaves me with negative y equals negative 3x and a minus 2. And then I would just change the sign of everything because of that negative y. So what I'd actually be graphing is y equals 3x plus 2. So that means put a 2 where the y-intercept goes, and then up 3, right 1. There. We need to draw a line through that one. Like that, maybe. Then let's go back and graph the other equation, which would be a lot easier. X and y are together here, and to me this one seems easier to just do it as an intercept method. I would say x is negative 4 for the x-intercept, and the y-intercept negative y equals negative 4, so y is 4. So on the x-axis, go over to negative 4 here, and on the y-axis, we're going to go up to positive 4. 1, 2, 3, 4. Right here. So again, we're going to draw in a line on this one. And we can see the intersection point right there. So once again, we need to highlight that intersection point, which is up here, and say it's over 1 and up 1, 2, 3, 4, 5. The solution to this one is 1, 5. So that deals with graphing equations, 2 possible examples there, but they're systems of equations. So all the old graphing of equations that we used to do where it was just graphing one line, this stuff covers all of that and in fact takes it to another level. So one of these problems will be enough for sure. All right, the other step of that is to graph inequalities, which is what we have here. Number 44 is missing a number. Let me fill it in for you. I'm pretty sure it's 3 over 2. And it is 3 over 2. So we need to graph number 44. You're going to put them on the same x and y axis. So number 44 says, okay, do the first one at positive 2 on the intercept right here. And then the slope says go up 3 and right 2. So right here. We have an inequality with a line underneath of it, so that's telling us that we need to draw a solid line in there. So we have a couple extra steps involved here. Let's change the color of that and make it match. And because we need to shade these, this one is greater than. So when you shade for greater than, you want to shade up from the line. So if you put your pencil on your line and just go upward, that tells you which area to shade. So we need to shade this area and this part up here. The other graph is x is less than 3. If you notice there's no y in this one, so it tells you it's either a horizontal or vertical line. When it's an X by itself, that is a vertical line. And in this case, the less than symbol tells you that there needs to be a dash line instead. So it says put a vertical dash line where X is 3, which is right here. So we need a vertical dash line running this way. Okay. And because the shading is less than, I'm going to shade it to the left. Right? Where's all the stuff that's less than 3? This way. What we're really looking for out of all of this is where the shading overlaps. And you want to make sure that that area stands out. So to me, the overlapping shading is right here. It runs right along the green line and then also where this dash line is. So the overlapping shading is this area that I am highlighting in black right here. You want to make that area stand out, so I would then show that this is your solution right in here. Okay. So we have basically the same task in the next problem. This time we have a y by itself with no x. This is a horizontal line where where y is 5. So we need to draw a horizontal line. I'll do that one in purple, I guess, where y is 5. It's going to be a solid line because of the equal to symbol. So 1, 2, 3, 4, 5. We have a horizontal line going this way. And the shading, because it's less than, should be downward. So from the line down. This whole bottom half will be shaded. And the other one, this is a normal inequality. We have a y-intercept at -4, so down here to -4. Then our slope is a 3. We know that should mean 3 over 1. So up 3 and right 1. Another one there. This is going to be a dash line because of the normal inequality. So we have a dash line like this. And the shading for it is greater than, so I'm going to go to where that line is, and I'm going to shade up from it. So I'm going to go up this way again. So if you notice out here, a lot of this shading is not overlapping, but then all of a sudden it starts to. So sometimes these things look like a big mess, but the truth is that what you really need to say is where is the overlapping shading. And most of you on that last test did pretty well with this. You can see the overlapping right in this area. And again, you want to make it stand out. Okay, that's it for page 6 and 7.